Today we're going to do transformations of the basic graphs of y equals cosine theta and y equals sine theta. And so we're going to stretch and shift and compress using the transformation rules that we learned all the way back in, earlier this year. I think maybe chapter 2. It was a long time ago. All right, so here we go. We're going to start out with the first one, which is a vertical scale change. Okay, and what this affects is the amplitude of the function. All right, so if we have y equals cosine of theta and we put a 5 out in front of it multiplied by the cosine of theta, we remember from our transformations that this means that the y values are times 5 or 5 times as tall. All right, so how does this look? Well, it's still the cosine curve, but instead of 1 and -1, this graph is going to get as high as 5 and as low as -5, but everything else stays the same. We finish at 360, 180 is halfway, 270, and 90. All right, see how easy that is? If instead of 5 times it, let's say we had y equals 1/2 sine theta, right? Same thing, it's the sine curve, but instead of topping out at 1, it's going to top at 1/2, and the minimum value will be -1/2, same x values. Okay? Easy stuff. Let's move on. The next transformation we do is a vertical shift. And so in order to do the vertical shift, I have to define this thing called a midline. So if this is y equals cosine theta, when I graph it, the line y equals 0 is the midline of the cosine graph. It's the horizontal line that balances it, cuts it right in the middle. Okay? When we have a vertical shift, we are simply shifting the midline. So let me show you what I mean. If I have y equals 8 plus the cosine of theta, all right? We, instead of y equals 0, we're going to put a new midline in at y equals 8. Okay? And so then we're going to graph the cosine of theta. Everything else is the same. So from 8, we're going to go as high as 9, as low as 7, right? And we're going to start up, and we're going to draw this graph and end again at 360. And I think it's easiest when you change that midline to go ahead and put your x values there, and then 90 and 270. All right, so this just means to move the entire graph up 8. Okay, easy enough. If this were a negative value, let's go ahead and try one that has a vertical shift and a vertical scale. So what about if I have -2 plus 6 sine theta? All right, so let's put the two of them together. Start here with the new midline. All right, so here is y equals 0. I'm going to go in and put in my midline at y equals -2. From -2, this means that I stretch instead of up 1 and down 1, I want to go up 6. So from -2, I'm going to get as high as 4, because -2 plus 6 is 4. I'm going to get as low as -8, right? But it's still the sine curve, so I'm going to put my dots in here and connect them. And this is the graph of -2 plus 6 sine theta. Again, 180, 360, 270, and 90. How are you doing? Following me? I'm going pretty fast. All right, the last transformation we have to do is a horizontal one. And this one affects the period of the function. All right, so just as a review, y equals the cosine of theta has a period of 360. What that means is that after 360 degrees, right, the pattern repeats. And then it repeats again after 360, and you get the idea. Boy, that's really bad drawing. So we're going to put values in here between the cosine and the theta, and it's going to affect the period. All right? And so we might say, let's graph cosine of 2 theta. Right? So what does that 2 mean? The 2 means there are 2 cycles in 360. All right, so this value here, the one that changes the period, says instead of completing one cycle in 360, we want to get 2 in 360. All right, and so if 2 cycles are in 360, that means that the period of this function is 180. And so in 180 degrees, we're going to complete one cosine curve. Now we have to scale the x-axes, and so halfway is going to be 90, this will be 45, and this will be 135. Okay, does that make sense? If we have, let's try a sine one here, the sine of, let's say, 1/2 theta. Now we're saying that 1/2 of a cycle in 360, so one cycle takes 720 degrees, right? So here's the sine curve, and it's not completing a cycle until 720 degrees. So this is now 360, 180, 270. All right. There's a shortcut here. You're wondering about this whole cycles in 360, and so here's the shortcut. And you'll want to use this. Whatever the value is between cosine and theta, this number here, you take 360, we're going to call it C. C stands for cycles, so that's easy to remember. And we're going to simply take 360 divided by C, and that will give our period. All right? So if I have y equals cosine of 3 theta, we're going to take 360 divided by 3, and that means that one cycle will be completed in 120 degrees. Does that make sense? Okay, so what I thought I'd do is I'd leave you with one problem where I add all 3 transformations. So we're going to together graph y equals 6 plus 3 sine of 1/3 theta. Okay, and the way we graph this is we take care of each of these one at a time, and we do them in exactly the order that they're here. Okay, so the 6 means we have a new midline at y equals 6. Okay, check, got that done. The 3 means from 6 we're going to travel up 3 to 9 and down 3 to 3. So that will be our highest y value and our lowest value. The 1/3, when we take 360 and divide by 1/3, that's the same as 360 times 3, and that turns out to be 1080. And so what we're saying is that this cycle of the sine curve is not going to finish until 1080 degrees. All right, so then what I like to do is I like to put the points on the new midline, right? So I know that my sine curve is going to start in the middle, go up to 9, go back to the middle, down to 3, and then I make my smooth curve, and I'm almost done. I just need values here, here, and here. So half of 1080 is 540. Half of 540 is 270. So 270, another 270. When I add 270 to 540, I get 810. And so this is a complete graph of this, and you will be practicing that a lot in class tomorrow. See you in class.